Which one was mine?
That one.
Okay, welcome everybody. I can see some new faces, so I'm very glad. My name is Tom Breza. I'm a host. This is Tristan Brindle. He's our main teacher, tutor. There is another guy running here with a hat. You recognize him. Only Tristan with a hat. That's him. That's Oliver. Yes, he's another tutor and obviously helps us as well. We got here another professional photographer called Justin. He helps us as well. So that's the experienced developer. So if you have any issues, any problems, raise your hands. These guys and I'll, to my ability, will try to help you. So first of all, thank you very much for coming. I know C++ is difficult, and obviously it's glad that you're coming back. So that means we're doing something right. For those who are new. This meetup is completely, totally voluntarily run. So basically, none of us is getting any money from anyone. We're just doing this because we do want to help other people. But because of that, obviously, we want to make sure this meetup is sustainable. But before I go to that part, I would like to say massive thank you to people who already went to GoFundMe page and they put some money for a laptop. We're trying to replace a laptop for Tristan because his laptop died. At the moment, he's using a borrowed laptop. Obviously, Tristan is using this for the slides most of the time. So it's a good idea to help you. So if you decide to help, if you do want to help and support our meetup, how can you help? The most obvious and the best one is if you know any sponsor, any corporate, any business that would like to work with us, send them towards me, and we'll discuss. We'll figure out what we can do for them, so they will see the value for the money. Because we always want to keep the meetup free for you. Yes, we don't want to charge our students. Another option is. There's a couple of heuristics. If you need a bootable working operating system on your laptop or desktop, so you don't have to install, you can use a Linux-based operating system with CLI pre-installed compiler and so on. So it's fairly easy to start. Memory stick costs us £7. We recommend the price £15. Obviously, you can pay more if you want, but only buy if it will help you. As I mentioned earlier on, we're running the GoFundMe page. I don't have address at the moment with me, but ask me or go to our YouTube stream. It's almost with every class which we record, there is a link to that. So if you decide that this class is benefiting you, you're very welcome to help us. Finally, yes, once the class is finished, you're very welcome to go with us to pub and buy these two guys a couple of beers, maybe some nice hot food. So that's all. I have a question for you. Does anybody reading my blog posts? Hands up.
We didn't even know you had a blog.
On our website, cpplondonini.com, there's a blog section.
Sometimes. You just say that because you feel guilty.
I mean, I'm trying to.
At the end of the session, there's going to be a quiz on what.
Yeah. Okay. There was a bit of gap, but generally speaking, once a week I try to put some updates and everything in one place. So you're very welcome to join in. And there's a couple of photos, so you can share them among friends from the class. So you're very welcome to go there.
I don't think you're sending out the email notifications.
I think I have to start doing it.
I've taught you how, so you can now do it.
Sort of. I tried last time. It broke the website, which was unbreakable. And then we had
you broke the website when you tried to reskin it and you just wiped everything I'd done.
And then we have the partners network join in selling Viagra on our website.
Oh yeah, Tristan's account managed to get that. So he times.
On the good news, we have a new chapter. Yes, there is another C++ London Uni. Obviously, it's not called C++ London Uni. It's called CPP SF Bay Area Uni, and obviously it's happening in California. So Michael Close is decided to run a copy of us in California. So if you know a chapter,
I like how it's aimed.
a covenant, like vampires and.
No, I like how it's aimed.
Like
I
witches.
like how it's aimed. It's a new chapter.
So basically, if you are in California, you want to join, you're very welcome. Or pass to your friends if somebody is there. Just a reminder, our classes are weekly, so we are happening once a week on Tuesday for our class, and on Thursday we have workshops. Workshops are as equally or probably even more important than class, because during the workshop, your job is to use the knowledge which you acquired today with exercises. So the next time you actually really learn, not just listen, but learn. This is the big part that which makes put us aside from YouTube videos, Udemy videos, Pluralsight videos, and so on, because you actually have a chance to practice with people who will do the same. If you want the most up-to-date information, please do follow me on my Twitter, which is xvms. We're working on somebody else to overtake that responsibility, because I'm not that very too old probably for that. But for now, until
Come on,
that,
Donald Trump can do it.
please do. And finally, I have new batch of the licenses. So if anybody needs it, let me know. And RSVP as soon as possible for the classes, so we can guarantee space at Skills Matter. That's all from me. I'm passing to Tristan.
Here it comes.
All right, good evening, everybody. Thank you for coming again. Yes. A question before we've even started. This is a first.
Is your name Tristan or Christian?
Tristan.
Okay, because Tom keeps calling you Christian, so I'm going to.
I've given up correcting. Yeah.
Have you seen any of the blog posts? They're just like a sequence of English words, really.
Yeah.
No, I'm just kidding.
Apparently nobody's seen the blog post. So anyway, yes. As you can see, those who've been here before, since last week, Oliver has grown some rather questionable facial hair. Allegedly, it's for charity, although I suspect come December it's still going to be there. But anyway, no, it is for charity, and if you want to support him, please do go to that URL and donate. The cause is
Testicular cancer, and well, I think they've expanded now, but it started out as testicular cancer. Mental health now, yeah.
definitely a worthy
Very
cause, and he's going to look like an idiot for a month, so I think he should all...
Are you going to start wearing sombrero?
This is a partial idiot. I mean, it's Mover, not sombrero, robe, and
To go with the moustache.
Huh?
To go with this moustache.
the stereotyping.
Anyway, that's the URL. It's also on the board over there. Please do go to it and donate some money. It's all for a worthy cause. Right, on with the show. Welcome to session 2 of module 2. So last week, if you remember, I hadn't yet come up with a title. I decided to go with custom types. There was a suggestion for a slightly longer one, but custom types is nice and pithy. So yes, that's what we're calling this module. This is module 2. So C++ 102, I guess you could call this if you wanted to. Normal first slide. We do like to hear from you. We want you all to join our Slack channel so we can chat to you, so we can give you notifications, so that we can, you can talk to us. All of that usual stuff I say every single week. So if you haven't yet done it, please do go to that URL, pop in your email address. It'll send you an invitation, and you can join us on Slack at that chat room. I mentioned this the last couple of weeks, but just to do it one more time, Ollie has spent many hours in front of his computer recording some live coding examples about doing about test-driven development. It's a little ahead of what we're doing in class at the moment, but if you're confident with all this, if you feel like you already know all this and you want you want to go a bit further, I don't expect you to memorise those URLs, but they'll be on the slides, or you can just search for C++ London Uni on YouTube.
Just go to youtube.com/CPP London Uni.
Or that, youtube.com/CPP London Uni, and they're on our YouTube channel. There is, what is it, about 6 hours worth of video there. So
Yeah, it's more than I banked on, but you get to see it complete from scratch, TDD based implementation, and a lot of it is my thought process. Play it at 1.5 times. Hopefully, I'm talking too fast for you. There's auto subtitles, which are questionable but not too bad.
get the photography out of the way. Okay, so last week we started talking about defining our own types in C++. In particular, we used the struct keyword. And then we went on to talk about member functions, what they are, how they work, how you write them. So that was last week. Hopefully most people remember that. If not, well, we'll go over it again very quickly in a few minutes. This week we're going to talk about member functions some more. In particular, we're going to talk about separating the declaration, the definition of member functions. We're going to talk about function overloading. You might already have done a bit of that without really realising it. We'll go into that in a bit more detail, and then we're going to talk about operator overloading, which is very important when it comes to our own types. So, last week's homework, which I've apparently forgotten, usually I'll copy it onto a slide next week, but I've apparently forgotten to do that. But who had a go at last week's homework? Oh, quite a few of you. Excellent. Who managed to do it all? The same hands go up. Awesome. As usual, I've put a solution up on GitHub. So, yeah, why don't we have a very quick look at it. At this point, it would be very helpful if I had the actual problem definition. So if you bear with me just for a moment, I will find it. Right. Oh, there was lots to do this week, wasn't there? Okay, so first of all, I wanted you to define a new struct student with 3 member variables. First name and surname, both strings, and an integer ID. So I did this all in one file. Didn't have to. So it's grown a bit because we have a few more things on there for later questions. But basically, I wanted you to define a struct student. And I wanted 3 member variables: a standard string first name, standard string surname, and integer ID. So hopefully, most of you managed to do that. So that's a change the default initializer for student ID to use an incrementing counter. So the first student you create should have an ID of 1, second should be 2, third 3, and so on. So there are quite a few different ways to do this, one of which, the simplest, which I've done here, is just to have a global variable, which I've called ID counter, initialized to 0, and then every time we create a student, if we don't supply an ID, it's defaulted to ID counter plus 1. So this plus plus pre-increment, it increments ID counter, that is, it adds 1 to it, and then returns the new value. Right? So this does exactly what we asked. The first time we call this, ID counter is going to be 1, the second time it'll be 2, and so on. Yeah?
I tried to do it inside. I didn't try to use a global variable. I'm saying I did it, but I tried.
Okay, so if you used an ordinary member variable there, It's not going to work because your counter will be associated with that struct instance. So
Yeah.
So one thing you can do is you can use a static member variable. We haven't talked about static member variables yet, which is why I didn't use it for this example. That would actually probably be a better way of doing it. You keep all things in the same scope. So people who did use a static member variable, well done. Another way would be to have a function that returns a new value every, get next ID or something that has a static variable inside it. So say various ways to do this. I think this is the simplest, so that's what I went with. Part 3, add a print function. Print member function to student, which print out the name, surname, and ID number separated by spaces. So you can see that right here. So this is a member function. It's inside our struct definition. It's a function called print. Takes no arguments, returns nothing. It has this funny word const on the end. Anybody tell me what that means? Doesn't modify the student struct. It's a little bit stronger than that. It cannot modify the student struct. Right? This means that we are allowed to call this function on a read-only instance of student. Okay? Because if you think about it, when we're printing things, we don't need to change any values, right? We're just reading them. So we say, this is a promise, guarantees that this, well, more or less guarantees that this function doesn't modify any of our member variables. And then this is just a normal print statement that you've seen lots of times already. So next, define a new struct module record with 2 member variables, a student, and an integer grade. So here we are, I've done exactly that. Now really the idea of getting you to do this was to show you that you can use your own types inside another. You can use a user-defined type as a member of another user-defined type. Right, so all the examples I did last week, we just used built-in types like ints and floats and things. But this is showing you that you can, you can define this type here, and then you can have a student as a member variable of another custom type, which is very useful. So skip that compare grades for a moment. We'll come back to it. So then I wanted a new struct module with 2 member variables. A string containing the name, you can see it there, and a vector of module records containing the grades. So there you are. And again, the idea behind this was to show you that you can use your own custom types in a vector. A vector is what's called class template. It's an array, a collection of something. We put it in angle brackets, and provided they meet certain criteria, which our types do, you can use your own types inside a vector. So this is exactly what we're doing here. So then I asked you for this add record member function. So this returns nothing, takes a const reference to a student and an integer grade. And what I wanted you to do was to add, when somebody calls add records, to add a new module record to this grades vector. So you'll notice this member function is not marked const. Right? There's no const keyword here. And the reason for that is some whispering, but I didn't catch it. Yeah, we're going to modify our grades member in there. Right, so because we're modifying it, obviously it's not a read-only function, right? So it's not const. And then within the member function, we call this pushback member function on vector. So if you've used vector, it's the way you insert things into the back of it was with this pushback.
Just to be clear, the const part, you're referring to const on the member function, not on int grade.
Yeah, the const at the end there.
Just to make it clear.
Yeah.
Int grade could be fine.
Why not? Sorry, can you explain again? Why not const in a grade?
No, you could make.
you could.
You
Oh,
could do
okay,
const
sorry,
at grade,
sorry.
but you couldn't put const at the end of the whole line.
Oh, yeah, okay, yeah.
Okay, now,
Very good question.
yes.
When you're doing the pushback onto the vector,
Yeah.
why have you used curly braces?
Okay, this is what I was just about to say. So, grades, or the vector of module records, it knows that it is a vector of module records, right? It knows that's the type it's expecting to have in there, right? So, this is a sort of convenient shorthand. We could have written the word module record in there to say, okay, I want to create a new module record, and then put the curly braces to actually construct it. But actually, because it already knows that's the type we're going to pass, we can omit that. We can just use the curly braces. It's just a nice little shorthand that I wanted to show off. That was add record, and finally print. Or almost finally. So again, just the same as we had before. Print is a read-only function, doesn't modify anything, so we can make it const. And then in here we're going to use a range-based for loop that we saw 3 weeks ago or so. So for each record in our grades vector, and here again we're not modifying the records, so we're capturing, but we don't want to copy them either, so we're capturing by const reference. And I could have written module record in there, but just to save some typing I went with auto. So for each record, we're going to call yes, here we go. So we have the record. A record consists of a student and a grade. So first of all, we access the student inside the record, and then in the student, we access the print member function. Right? So we've got two sets of access happening here. So this will print out the student information, and then we follow that with a tab just to try and line things up nicely. And we print out the grade, record.grade. Okay, then there's a bit of an extension. So who managed to do this part up to here? Yeah. So the last one was just was not.
Yeah, we got 1 point from online. Someone's made, I believe, is a good point, which is that couldn't you have used it in place back and perfectly forwarded the arguments?
No.
Yeah, go
Well, we'll talk about this more next week about constructors, but in place back only doesn't work for aggregates.
What?
In place back doesn't work for aggregates, you need a constructor.
Yes, of course, because module record is an aggregate, yes.
Yeah. If you don't know what any of that means, don't worry. By the end of next week, you will know what that means. So as an extension, I asked, it wasn't really anything to do with structs or anything we did. I just, I like to push people a bit who like to read on. So what I wanted you to do was to print out the grades. So do exactly what you did in print, but print them in order, in descending order of the marks. So the highest scoring student gets their name printed first, then the next, and so on. So for that, you needed to sort the grades vector. And luckily for us, there's a function in the standard library called standard sort. It's one of the many 100 or so algorithms that are in the standard library. So again, this was an extension, so I'm not going to go into it in too much detail, but I made it even harder by requiring you to pass a custom comparator. So what happens is that, first of all, this is a const member function. We can't modify the grades member. So what we do, we start off by taking a copy, right? Because we can't modify grades, so we take a copy of it. And then we sort the copy. So we start at so grades copy is going to be a vector. we sort from the beginning of the vector to the end, and then as a criterion, so how do we sort the grades? We use this compare grades function, and what it does is it returns true if the first compares two module records, because this is a vector of module records, compares two module records. If the first has a higher grade than the second, then it should be placed first in the sorted order. And then the print statement is just the same range-based loop that we had above. So this was a bit sneaky. It has lots of things we haven't covered yet. So if you didn't do this, if you didn't manage it, don't worry. If you did, well done. It was deliberately, a bit tougher. Yeah.
Question: if you can go up to where it's the module structure.
Yeah.
I know you want to.
That's the one.
Yes. So. So one of the module struct had another member element called, I don't know now. But what my question was, I'll ask you later on.
Yeah. Okay. Next question.
I have two questions. One is relating to the print function.
Yeah.
That you say we have to pass as a copy because we cannot modify the. I passed argument which was const module m, but the module was like a reference thing. Now, when I'm applying my sort inside, am I changing or not? I'm a bit confused. Am I changing or I'm creating a copy? No, I'm creating a copy.
I'm not sure from your description. Maybe Ollie can have a quick look at the code there.
Okay, so I'll ask you just a second question.
Yeah.
You know when you have a structure with more elements, like
Yeah.
in student, you have name, surname, and the
Yeah.
ID. Can you create, if you have many students, for example, every one of them has their own name, their own surname,
Yeah.
their own ID. Can you create a vector only with one element in the structures, like with one vector only with all the IDs?
Yes, you can. In fact, I'll show you that in just a moment. In fact, I'll show you now. Okay, so I wrote a few test functions. Hopefully, you did as well. That was part of the homework. So, for example, make sure we can create a student. James Bond obviously has ID number 007. Make sure the automatically assigned IDs work, and so on. So somewhere down here, yeah. So this is what I wanted to show you. So here we create a module, and in one go, we first of all set the name, and then these brackets here, we're now initializing a vector, and in each vector, we create a module record. Inside each module record, we create a student and their grade. So this syntax for creating, vectors and things is actually quite neat, I think. So is that what you were asking for? How we can sort of do this in one?
Because this will have all the elements. I was thinking if we could create a vector only with one element in a struct, only for example with IDs.
Right.
All IDs in different variables.
Oh, I see. So you'd have like you're
Like
more.
James Bond, Tristan, Tom, only their IDs or only their names.
Yeah. So you'd have to create a new vector just of ints and copy each ID into the new vector. Yeah. You can't have a vector of references in C++. Yep. So that was the homework. So well done to those of you who managed it, particularly the last part, because it was intended to be challenging. Let's get back to it.
I think most of the people that came to the workshop got through it okay. If not all of them.
Excellent.
Good to meet you guys.
Oh. Okay, so if you want to browse it a bit more at your leisure, the URL is there. So it seems like at least the people who did the homework had a really good handle on defining these structs and things, but we'll very, very quickly race through. So struct, collection of data members, and member functions. All right, member variables, member functions. I said this last week, the word class does almost exactly the same thing as the word struct. Couple of differences in the defaults, but structs and classes both create new types. In the same way, you can use the keywords almost interchangeably. And so sometimes I'll refer to something as a class type. Even if you use the struct keyword, you're technically creating a new class type. So if I slip and I mix them up, well, it's because they're the same thing. As we've just seen in the homework, we use the struct keyword to introduce a new type, a new struct. And just something I mentioned last week, but can be a bit surprising depending on which language you're coming from. But two structs with different names are always distinct, even if they have the exact same members. Right? There's no what we call duck typing. Right? It's a strongly typed language. You can have two different structs with the same members. So we've just seen several of these. A member variable, sometimes called a data member. In other languages, they call it a field. It's a variable that belongs to the struct. So every time we create a new variable of a struct type, that variable has its own independent copies of its members. And again, just seen this in the homework. We write member variables using exactly the same syntax that we use for local variables within functions. I said this last week, but I'll drill it into you again. Always use member initializers like these. Unless you really, really know what you're doing, it's always best to, you never lose by putting them in, let's put it that way, right? So, yeah, don't be lazy, just give yourself a, yes?
Yeah, from the code that you showed.
Yeah.
The member variables, you brought like the strings, you brought the curly braces.
Yes.
Why that?
So that's saying I want you to, if I don't specify what this is, if I don't, like when I create my type, if I don't give you a name, just create me an empty string. Right? It's what's called a default constructor, right? We'll learn a bit more about this next week. But it's saying just initialize this with an empty string, so a string that contains nothing. So I could do the same for an int, for example. I've done equals 0, but if I just put an open and closed curly brace, that would have done the same thing. Initializes the int to 0. So that was member variables. I told you we were rushing through, right? But this was last week. So we also talked about member functions. These also get called methods in other languages, although, well, yes, they get called methods in other languages. And it's a function that belongs to a struct. So I sort of dropped a bit of a surprise on you last week that for all this time we've been talking about functions in C++, and that was only actually half the story. Because the kind of functions we have been talking about up until last week, we only ever talked about free functions or non-member functions, functions which don't belong to a struct or a class. But we also have member functions. So two types of function in C++. Member functions, non-member functions. And member functions always operate on a particular instance. So we just saw this in the homework, right? The print member functions, for example. You called something .print, and it printed the members of that struct. So again, just as for member variables, we can use the same syntax as we use for free functions. To declare a member function, we just put it inside the struct definition. Right? So this is saying struct point has two member variables called x and y, both of type int, and it has a member function called equal to, which returns a bool, returns whether, or hopefully returns whether 2 points are equal. You're about to say something, Tom.
Yes, where's return?
Well, I haven't supplied the definition of this function. I've just. So this is just a declaration.
Oh yeah, okay, sorry.
But we're going to talk a little bit more about the difference between member function declaration and definition in a couple of minutes. I think this is the last revision slide. Now we've to access the members of a struct, we use the dot, full stop, dot. Right, so we saw this before. We had the record variable that was called rec, so we did rec dot student dot whatever. And within a member function, within the body of a member function, within the definition of the member function, we can just use the names of our member variables just by writing their names, right? We don't need any sort of prefix like in Python you normally do self dot whatever. In C++ you don't have to do that. Last time we were going through this a few months ago, I said this, and it helped some people get a sort of clearer idea of what exactly a member function does. If it doesn't, if you find this bullet point confusing, just ignore it. If you think you already understand member functions, great. Just ignore what this is saying. Okay? But you can think, if it helps, you can think of a member function as being sort of like an ordinary function, except it gets an extra secret hidden parameter passed to it, which is this, the thing we're operating on. And in fact, I say you can think of it. It turns out that's exactly how C++ compilers implement member functions. Right? But that's kind of a detail that's not really necessary to know. But you know, if it helps member functions sort of click in your brain. This I didn't say last week because I didn't want to sort of delve into pointers too much. But just as you can use self in Python, for example, to access the class that you're operating on, in C++ there's a keyword this. And this, within a member function, can only be used within a member function. The keyword this refers to the current object, the current instance that we're operating on. For arcane reasons, it's a pointer. Should be a reference. It's not. It's a pointer.
But the reason's not that arcane. It was that references weren't invented when that was invented, so it had to be a pointer.
Yes, that's an arcane reason. They've had 30 years to change it. Anyway, yes. So if you're not comfortable with pointers, don't worry too much about this. We're going to talk about pointers in the class, and everybody gets very scared with pointers. I don't know why, but
If you have only one member variable,
yeah,
and you call it x,
yeah,
can you just then use this rather than this arrow x?
no, you have to say this arrow.
Say
X.
x.
Yeah. Oh, I know I lied. We had one more revision slide. So, just talked about const member functions. So, if we put the word const on the end of the declaration, then that means that this function, you are able to call it on a const object. So have our friend point again, and this equal to member function. Well, it's just comparing whether the two points are the same, right? So it's only reading the function. It's a read-only function. It's only reading the member variables. It's a read-only function, so we can put we can make it const. Right? And within the body of a const member function, so within the definition of equal to, our member variables behave as if they were declared const. So that means that if inside the body of equal to we tried to modify x or y, the compiler would tell us we can't do that. Within the body of a const member function, member variables are read-only. So this const at the end, it's const qualifier as it's called, it's const at the end of the member function, promises that the member function doesn't modify any of its member variables. Yeah?
Sometimes you see the const written before. And
Yeah.
Why is that?
Okay, so perhaps someone can say, if I wrote the word const here, first of all, is that valid? Will it compile if I put the word const here? Yeah? Okay, what will it mean if I put the word const here? Exactly. So when we write a function, it starts with the return type. So if we put const here, that const would be part of the return type. Yeah. So we'd be saying we're going to return a const bool, which would be
Meaningless. It is literally meaningless.
worse than that actually, but yes.
No, the compiler issues a warning saying that const on by both return types is discarded.
Actually inhibits move assignment from custom types. It's actually worse than
It's even
useless.
worse, yeah, that's true.
Yeah. For fundamental types like bool, it makes no difference. Yes, right. So I ran through const member variables very quickly last week, but actually, you know, by the sound of things, people actually managed to get a good handle on it, so that's good. So here, just showing in a bit more detail what was on that last slide. We have our struct points with this equal to member function. And we're just returning whether x is equal to others x variable. So other is another point. So this is whether our x, remember, a member variable operates on an object. So it's whether our x, this x, is equal to the other x. And this y is equal to the other y. If both of those things are true, this function is going to return true. If either of those things are false, this function is going to return false. So we create a couple of points, P and Q. So if P is equal to Q, we do something.
Do you sometimes check is other equal to this?
You do that in assignment operators. You do if the address of other is the same as this. So we're not going to talk about assignment operators for a little while, but you want to avoid self-assignment. So you check whether the other object has the same address as the current object. That's where you'd see that normally.
I thought the point was as an optimization. To avoid making a bunch of comparisons, you could.
Yeah, whether it is or not.
Well, it depends on the object.
All right, so that was last week's material. Gives us an hour and a half of new stuff, right? Yes.
Sorry, I missed that last part. What's other? What's that?
Okay, so let's go back.
Yeah.
Oh, that's
So-
just the argument.
Yeah, so this function takes an argument called other, which is of type reference to const point.
Yeah.
Yeah.
I got confused because it's italic here. I thought it was,
Oh, it's just
a
the-
type or something.
No, it's just the syntax highlighting. I've copied and pasted this from the IDE.
What ID did you copy it from?
C-line
Does this, that copies with the syntax, with the code?
into Keynote, yeah.
That's cool.
Okay, any more questions on last week's stuff? We've seen the homework, we've raced through what we did last week. All good? Cool.
Yes, no.
Another one.
Sorry. Maybe I'm getting ahead of myself, but is there a difference between structs and classes? Is there any difference?
Or is it
There are the only differences are in the defaults. So anything you can do with a struct, you can do with a class. Anything you can do with the class, you can do with a struct.
You have to write it slightly different.
If you really want to know, when we get on to talk about if you've done any other languages, Java or C# or whatever, you probably know about public and private and protected variables. So classes, member access defaults to private, in structs, everything's public by default. So that's the only difference.
And it's inherited.
Well, all right.
Just out of curiosity, why did they build two different things like that?
So C was C++ was originally called C with classes. Right. So the idea was it was a set of object-oriented extensions to C, because this was 1979, 1980. Like object-oriented programming was really just coming into its own, really popular. So the class keyword was like the object-oriented word. Structs were inherited from C, and I mean, there's really, I guess, there's no need for the class keyword. We could get along perfectly without it.
Because of Simula. Gunner was inspired by Simula, which used the class concept of class, which he really liked. So C++ got the word class, but yes, of course, C already had struct. And it made sense that since the struct in C, there is no concept of public, private, whatever, so it needs to reproduce what the C can do. So the idea was, of course, a class can keep everything private by default, and the struct does not. You can obtain identical functionality from either. You just have to write it slightly differently.
Okay, so our favourite topic, header files. Header files and implementation files, the bane of the C++ programmer's life. We know, we've said many times, hopefully you're used to the idea now, that we separate the declaration and the definition of functions, usually. So usually we write a function declaration in a header file where it can be reused all over our project. And we write the definition in one place in an implementation file, right, which gets compiled separately, and then I had those lovely diagrams showing how the linker resolves all your function calls. With structs, when we have our own custom types, we will probably want to reuse those types in our code, in other parts of our code. So we need to write our struct definitions inside header files, because header files are the bits that get shared between our what are called translation units, between our compiled source files.
Probably should point out that the struct definition does not include the definition of its member function. Oh, sorry, go on.
Right. So we need to put the struct definition in a header file, right? Because that way the compiler knows what the member variables are, knows how big the struct is, it knows what the member functions are called, what argument types the member parameter types the member functions take, what they return, that sort of thing. So we put our struct definitions generally in header files, so they can be reused. So just as we put function declarations in headers, we also put struct definitions in headers. So a member function is declared inside a struct. That's what makes it a member function. But just as we can declare and define non-member functions separately, we can declare and define member functions separately. Right? So it's not really any different to what we've already seen with non-member functions, ordinary functions. Right? The declaration, the header, definition in a CPP file. We do the same, often do the same for member functions. Right? The difference is, as we've already seen, you are allowed to write the definition right there, right in the class. Right? We've already seen that. That's what I did in the homework solution. Right? You are allowed to put the definition right there if you want to, in the class. So typically, if the member function is very, very simple, right? It just like it's one line, right? Very simple. We'll put it in the header file. We'll put it in we'll write it in class, as they say, in line. And if the member function is more complex, it's quite a few lines of code, then typically we'll do what we do with for non-member functions. We'll place a definition separately. Okay, so simple functions go in line, complicated functions go separately. Now, exactly what constitutes the border between simple and complicated is, it's a matter for debate. But this is sort of a rule of thumb, I guess. If it's more than a couple of lines, it's usually better to put it in its own file. But there are such a wealth of exceptions to that it's not. I'll hesitate to call that a rule of thumb. So Tom,
sorry.
criticised me earlier.
No.
I hurt Tom. It hurts. Tom always uses abstract things like
Okay.
points. What's a point?
Okay, I advise like maybe it would be easier if we use all the complexity of C++. So if we have some abstract thing, which might be confusing, to use more non-abstract things like dog, car, animal, and so on. So then we know, oh, okay, this is our thing which we create, not some sort of magical word.
So I can't even count the number of times I've been at work and being like, yeah, class dog, that's coming up.
Well, here we are now. This is my effort to follow Tom's advice and use how would you say it? Concrete things rather than abstract notions like points and ints and numbers and things. So, we're struct dog. It's got a member function called bark. And this is a declaration. So, just as with free functions, we can see the declaration ends with a semicolon. It says, there exists, so dog has a member function called bark, takes no arguments, returns nothing. Right, this member function exists. We don't know its implementation yet. Another member function called wagtail. This one's const. Doesn't change the state of the dog. That's actually not a very good example, is it? But I'm sure it would change the state of the dog. But in principle, anyway, for the purposes of this example, wagtail promises not to change the state of the dog. And again, you can see that the const is part of the declaration, right? So the semicolon goes after the const. And because I wanted an example of something that was very simple that I could write in one line, we've got this member function called getNumLegs. We've got a nice, healthy dog, so he's got 4 legs. So this function takes no arguments, returns an int. Doesn't modify the dog, just counting his legs. And, surprise, surprise, returns 4. Right, so this is an inline definition. It's a definition we've written right there inside the dog struct. Right, so this both declares that this member function exists and defines it. So here we've got 3 declarations, one of which is also a definition. Yeah.
Why do you need the semicolon
Where?
after the declaration of functions?
It just says, don't expect a function body to appear. Yes. Right. So this says, right. It's like a full stop at the end of a sentence. It says this function exists. Full stop.
Right. And for structs, you can't declare the member variables inside the header file?
You do.
Yeah, it just so happens that struct dog has no member variables.
Okay, so you can.
Yeah, no, you would. You have to. Yes, they always go inside the struct definition in the header file. Yeah. It just so happened that I picked an example, or I didn't give dog any member variables in this case.
So in this case, the header file is the declaration and the definition of struct.
Of what it contains, its layout. So that
Yes.
when you want an instance, you know how much memory you need.
Yeah.
So you don't have an implementation file for struct as such.
You do. You
But
do.
that's the functions.
Yeah.
So when I'm creating an instance, I need memory for its fields. I don't need memory for the functions. I just need to call those functions.
No, I get the function.
Yeah,
You
okay.
get the header's definition, and then you have a separate implementation file
With
with the
functions.
with the definition of function.
Maybe I can.
For structs, the struct itself, you define it, create it and define it in a header file, which is just shown by Kristen. But they won't need some. It can just now be called in other.
It can be included in other translations.
Yes. But it doesn't need some magical separate implementation file.
If there's any
Like a
function, if the functions are only declared, then yes, you do. You need a CPP file to, like those two, bark and wagtail.
Yeah.
You need a separate file for the struct to implement.
Yes.
So-
you don't need some magical other thing for the struct itself.
Not for the struct.
No, that file that implements those two will just include the header that we've already got, and then define them.
Question at the back.
So I was going to say, because they have struct dog has no what should I say, member variables.
Yeah.
Shouldn't everything be a const? Because you won't be able to change the state of the dog anyhow. The state remains the same.
Yes, that's a very good point. Which is why I've just rapidly added this member variable just to avoid any confusion. I didn't have the syntax highlighting because I've just written it in, but I've now added a member variable called hunger. It's a floating point. You could say if he's, if hunger's 100, then dog poor thing's about to keel over. But this is a lovely, well-fed dog, so by default he has hunger of 0. I've never known a dog with a hunger of 0, by the way. But yes, you're absolutely right. There is no state, so of course all our member functions could be const. Or there was no state until I added that. So this would go in our header file, which I call dog.hpp. Typically, when we write a class struct, we typically have an HPP file and a corresponding CPP file that contains the definitions of its member functions. So that's exactly what we've got here. The first thing we do is include our dog header. Right? So this just, as we've seen with header files, literally copies and pastes the contents of the header into the top of our CPP file. Also include IOStream because we're about to do some printing. And now, here we're defining, I should say, a function called bark that belongs to the type dog. Right? So if you think about it, lots of different structs can have member functions with the same name. Right? So for example, I've got a struct dog that has a function wagtail. I can have a struct cat with a function wagtail. So when we're defining these functions, we need to tell the compiler which struct's member we're writing. So this is saying I'm defining the member function bark that belongs to dog. Yes?
Sorry, you know the case of these HPP files out there?
Yeah.
If you don't define the function,
Yeah.
does that mean you can have different behavior in different CPP files?
Basically, if you try and do that, you'll get errors when it tries to link together your executable. So
you can only have you could do multiple separate definitions. When you generate an application, you must pick exactly one of them.
Yeah. So I could have, like, say for instance, I'm just thinking of it. Like, say could I have like a superclass saying like animal.
Yeah.
Yeah. Like student declaration, kind of like how interfaces work in Java.
Yeah.
And then in the other files, like say dog and cat, implement like bark or sound differently.
Yes. So that's something called virtual functions. So in Java, all the functions are virtual. You can override them in subclasses. You can do the same thing in C++. And we'll talk about that in a few weeks' time. But we haven't quite got there yet. But you're thinking very much along the right lines. You're just a little bit ahead. So, yes, we're defining a function called bark that belongs to the dog struct, right? And it returns nothing, takes no arguments, and that's what it does. It says woof.
At the risk of sounding somewhat facetious, what was the rationale behind making wagtail const?
This, because I wanted to show you when you define the function. So this is the same again. We're defining the wagtail function that belongs to dog, but we need to put the const on the definition as well. That was why I made a const.
Yeah, why is a dog? A dog, like how
Because Tom told me to use a dog, so I'm using a dog.
See, Tom? It's a terrible. What is a const dog? Is it a dead dog?
Yes.
It's the dog, you cannot change the contents of it.
You can look at the dog, but you can't touch the dog.
Sorry.
To make it more clear for me, but is why do you need to tell in this implementation file that it belongs to the struct dog? Because you have already included the headers HTTP file in this.
Okay. So imagine I didn't have this dog : here.
Yes.
If I just had void bark.
Yes.
What would that be? If you just saw void bark, open close
It's
brackets.
a function for bark, and this is how you.
Exactly. It declares defines a free function called bark, not a member function. Right? If I didn't have this bit, we'd just say this is a free function.
And then if this just happens to be another free function definition somewhere.
Yeah. But also, as I said, we could have another struct cat that has a function wagtail,
Yes.
right? And we could include dog and include cat. So then if we just said like void wagtail, it wouldn't be obvious whether we were defining dog wagtail or cat wagtail.
Okay. Cool.
Right.
Thank you.
So yes, the idea of making wagtail const was to show you that when you write the definition, it's very important you need to put the const on the end of the definition as well.
As I see it, is that now the member function bark can only be used on an instance of dog. That's how I understand it.
Yes.
So you have to define something as a dog, give an instance of a dog, and then only then can you use bark.
You have to use bark on the dog itself. You can't just do bark. Like, you
Exactly.
Say
dog,
dog dot bark.
So you can't say something like int something such and such, and then call bark on it, because it's
can't,
it's
yeah, because
assigned to the class dog.
Yeah, because if you have it in I, there's no I dot bark. There's no I dot anything.
Exactly.
Yeah,
That's
dog
why.
D,
That's
D
why.
dot-
That's why you do it. So I understand.
Because sorry, you only have like static classes in Java. You can have a dog class existing, not an instant.
You can have static member variables. Yeah, again, we haven't got to those yet. No, you're just running way ahead.
You do Java, then yeah, this seems quite simple.
Yeah. This is okay. So declaration, and definition. Right, and then down here we've got the two definitions of the functions there. We said this is the bark that belongs to dog. This is the const wagtail function that belongs to dog. Everybody got that? Lots of nods. Excellent. Prove it. For this, when I originally wrote this exercise, I'd already demonstrated this, but I don't think I've done it for you guys. After you create a new project in C-Line, you have the little project bar on the left. Right? If you right-click on your project, you can go to New, and then C++ class. And when you do that, it'll give you a little window. You can just type the name of your class, and it will create a header and an implementation file for you. Right? So that's what I meant by change the class keyword into struct. Or you can just create the files yourself if you find that easier. As I say, when I wrote this exercise, I'd already demonstrated that, so people were familiar with it.
Not to ruin anyone today, but LEWG is just deferred networking TS till C++ 23.
Yeah, it's not ready.
All right, my days are in. Carry on.
Well, we pretty much said that a week ago. Even Chris said that.
No, that was about executors.
Yeah, because executors aren't ready,
They're not.
and he didn't want
This is a pub discussion.
the TS minus executors.
All right. Well, Elizabeth.
Oh, not const member variable. Oh, what have I said? Oh dear me. I'm sorry. How embarrassing. So I've actually already shown you what this function should look like. If you're paying attention, you've already seen it. Just asking you to just practice separating the declaration and the definition.
Someone's on a report from San Diego, obviously. The various bits being talked about. I'm still scanning through it, to be honest. But I'm sure by the time we get to the pub, I'll look at most of it.
I look at the wiki. Do you know that they've got like this private wiki?
Yeah, it's the Ruby based one.
Well, I was only looking at it last night. Yeah, I was down to present a paper I completed on my submitting, and I was
Was
there.
that at San Diego?
Yeah.
You didn't. I don't remember you saying you'd be there.
No. But
No,
it got
Roger said
carried
he'd do it.
anyway. No, because I've forgotten to mention it. It was just a second revision. That's why I forgot about it. It was a second revision. Yeah, it got carried. I can just imagine them going, all right, Tristan.
No one needs help, raise your hand.
By the way, Ollie, have you just gone to see this new Queen movie? Is that what it is?
Oh, Freddie Mercury, eh?
I don't think he sings so well.
Oh, you did the first time. Yeah, you
But the same actor wasn't he playing Mr. Robot?
Did you see anybody who used
That?
Mr. Robot?
What's that? Mr. Robot.
Tristan.
Amazon.
This guy's basically scratch.
It's all yeah, I did that.
So, some Java experience. Do you try to use since you've got workshops, it's on generating P, so you know it's fairly not. So, yeah, C-line is made by exactly the same project. So, I since you already use it.
Oh, you created the default file.
It looks basically exactly the same.
The free trial.
It was just
My mere presence.
it was C line thing. do I add two targets, the class file? Because otherwise it won't teammate will cry or something.
So you create the class one, which one changes? Yes.
So we've got a chance. I won't disturb this. Promise. Right, that's trash. Wait, what? Oh. Tom, is this printed double-sided?
Yeah.
I'm not sure you're allowed to. I'm not sure you're allowed to print double-sided. I'll check, but... Oh yeah, this is fine.
I will Google this logo.
This is mostly good.
Oh,
Yeah.
you press up.
Press up arrow.
What's with the unicorn?
The known, like something like with a dog, yes? Names and variables which you can recognize easily. Unicorn is one of variables.
Yeah.
Hypothetically, that's what we need to do. Yes. There were some other things, various algorithms and things where I think the copy. Yes, so copy assignment is very important. So it's copy assignments, we always make sure other operators oh, those ones, Justin's just taken.
No, it's
Oh
yeah.
The first yes is going to be the second one, she wants another one. This one. What's wrong?
Someone else obviously had I think it might shift it. Set 10.
I'll have one.
Shift it.
Oh, there.
Well, you should. So maybe it's just a step through one step.
That's the second function. Another function, and then it's another function.
It happens every time we do one of these exercises. I like it will start off really quiet and then the noise gradually creeps up. Right? Which either means that people are finished and they just relaxing.
No,
Or they're stuck.
They finish reading the explanation.
Also, how this exercise the frequency? Okay, here we go.
What's the single top? What's the single step? Single step for each command. One step at a time.
Does not equal to.
Take this one. I've got a break point here.
Sorry?
So you go
Not equal to.
debug.
Another final equal to.
So what should not equal to?
Not equal. Sorry. Just that. That?
Okay. So now
Am I already running it?
X and Y are different. So if we say
It's gonna return. No, it's not true. It's gonna return true.
Error. Model debugging is not supported with Visual Studio.
Are you running a Visual Studio compiler?
No, maybe I don't know. I didn't actually set it.
Just
Yeah.
I'll go to the X settings.
so if the X's are different or the Y's are different.
That's right.
Build
Okay.
execution.
Well, it's an example.
Tool channels.
if you want to define the function, you can put there. It's just the exercise of writing. Exactly.
I don't have it because I need a Visual Studio.
It's just getting practice
So
doing
if
it.
I do some integer with an
Okay, first of all,
I don't
how to do this?
although
First of all, you can
I'm not going to try things out.
CSS.
Ah.
testing
Oh yeah.
you have to use Visual Studio.
Oh yeah.
Sometimes it's really slow and you don't
Exactly.
but yeah, it's much the C line is much better supported with them.
Oh wait, me you got
Sorry.
This is just download it.
Now we can
Shall we say a couple of numbers or straight away?
no, can I create a couple of points first?
Okay, so
It takes time to load it. Maybe want to give it
oh,
a
okay,
name.
yeah.
Give ID on my work. Yeah, have to.
It's really wrong.
No, because you need P is not equal.
No, so the function.
You could do it. Yes, we could do it. So you could do it C line. It's just a single header. So you should.
Yeah.
And then you have to ask why it's so slow.
Okay, so now let's try running this.
Let's
For some reason, it should. It doesn't link it for some reason. It doesn't run.
is it's wrong. It's very important. Yes, right. Oops.
No. Because you know you get this one.
Well, I'm not.
I've got the Visual Studio.
By the void function, throws
You normally do we're just making this point to see part of the object. So when you went to the right clicked and
Well,
Ah, doesn't belong to myself.
well,
this is when it's this course.
Sometimes there's
this ID tries to be sort of
No, I'm
otherwise we're trying to say.
oh yeah. Make it equal to that.
The reason that's
Well, if it was possible, so it's good to notice the error. Otherwise, all the ones on the Y is everyone's like this and stuff. Oh, no.
So I programmed sessions failed. So it's usually I do some code.
It's not fair because it is not equal. Or you failed because you yes.
So that's exactly what you want to do.
Okay.
So to say, it's just
So obviously, so the 18th minus 1, so I tend to hover around. Obviously, I've done lots of
Yes, thank you.
awesome. Well done.
So, answer. Yes. So, yes, so you start with this one. Okay, so this is the function. Yes, which is equal so you have the example shape. No, but this is they're different. Okay, you want to go. Yeah, another is the last one.
Okay, so we've written a function. So now, so this is a quite no, you don't need this as so now we just need to write that function.
This one, why don't you call this
okay, yeah.
and this is a constant function.
Okay.
Minutes.
Got education everywhere.
Redefinition of points. Okay, let's have a look in.
So identical again.
Okay, right. So points. Let's go to point A first. Point D. Okay. So what equal to
So my understanding of this statement.
sorry, what we've done here is we are comparing each points.
Yeah.
These numbers and here we're comparing so that's why actually
This is checking something against another.
so what you need to do and instead we need to hash include hash include
Yeah. Well, I guess. I'm not working.
Right. Okay, so now
We haven't done.
what do we function equal to 6 point returns a constant. It's not quite right. I want to say there's a function equal to that belongs to the last point.
Yeah.
So like with the dog example.
Yeah.
And what's it return?
I don't know.
True or false? Where you put the constant.
This is
Do the same for the equal to.
This is my second
So we need to say this is a function not equal to that belongs to the last point.
It's interesting actually.
So now, it's got underlined squiggles because it's saying we're not using this function. So if we go to main
It's like a test.
in fact, you can just press play.
Yeah, it's good to know. One. So what I did is so I put one function by ID.
Oh, okay. So
Inside.
if we click on that here. So you're saying this returns a constant because this is what we're saying about putting the constant at the end.
Oh, yeah.
Versus the beginning.
Okay, so at the end.
Put it at the end. Yeah, absolutely.
Which
Yeah.
I don't know. You see, this is it. Do I need? This is my question. Have I done too much? Do I need that?
Okay, is this going to work?
Why did you try initializing?
No. Okay, so out of line definition of equal to does not match any declaration.
So it's got the equal.
No, the declaration does not match because it is a constant value. True value. So the thing is now, under definition, under declaration, it's a constant. Under definitions, you haven't got constant. So you just need to force the constant.
Static.
Let's see.
So you've got has to be static. That's why I've tried lots of different. So hence I have to fix down. I think I have to have a constructor, which meant
No, we need to increase.
Oh,
I add one to the previously static.
Yeah.
So the idea
Magic.
is
So it's
it's just it complicates
and then I need to give an arrow, right?
because I found
And that will give us something to
well, the
yeah,
question
well,
was first of all, is there any other way of doing this?
Is that sort of how you test it? I was just
that's a perfectly fine way to test it.
one seems to work.
Yeah.
Yeah.
Seems to, I made those 2 points the same. Point 3 is the different one, so point 1
Okay.
So
point 2
here,
comes up 0. 0 is false. Yes, yeah. And then point 2 not equal to point 1. They're both the same.
I tried that.
Awesome, well done. Okay, looks like everybody's had a good go at that.
Because one, this is
So, so well done to everybody who managed it. I could have got a refreshment while you were all working, couldn't I? But I wouldn't do it now. Why not? It's there. So let's have a quick look at the solution. So I was going to do this live, but this laptop's not the quickest, unfortunately. So fingers crossed. Here's one I prepared earlier. So new presentation mode. Massive text. How about that? Okay, so we've got this struct points. It's got two member variables, x and y, giving them the default initializers of 0. And then I've said I've got a member function called equal to, takes a point, returns bool. It's a const member function. So only reads the only reads these members. It doesn't change them. And then I've got another member function not equal to, and this time, as I asked you to, you've declared it in line. So we've defined it in line. So we put the definition inside the struct definition. And all we do is return not equal to. So, yeah, we could have written that out kind of longhand, but since we've already written equal to, it's nice and easy just to write not equal to, right? So we can flick, hopefully, is that going to work? Yeah. Flick to the definition of this function. So this is a function called equal to that belongs to the point class. And again, we have to put const on the definition as well as the declaration. And here we just return whether our x is equal to the other x, our y is equal to the other y. So exactly as we saw on the example before. And then there's a shortcut for this, but I can never remember it. In main, we've just got a couple of little simple tests. We create a point P, which is 1, 2, x is equal to y, x is equal to 1, y is equal to 2. Q has x equal to 3, y equal to 4. So P and Q are different. So is P equal to P? Well, hopefully it is. Is P not equal to Q? Well, hopefully that's true as well. Is that going to let me compile this? No. Oh, yes. Run. And there you see it runs with no errors, so these assertions are passed. So I had a look around, and most of the people I chatted to got somewhere pretty close to that, so that's well done, everybody. Okay. Now for something completely different. Well, not completely different, but a little sort of side adventure. No? So we'll talk about function overloading, which is kind of simple idea really, but with quite deep consequences.
Maybe the overload. If you don't know this concept, maybe the overloading word isn't the greatest choice of word. Possibly function alternatives. A nicer way of thinking of it.
The basic point is this. We can have two functions that have the same name but have different parameter lists. That is, the parameters are of different types. Different number of parameters, different types of parameters. Right? We can have functions with the same name but different lists of parameters. Remember way back when we first introduced functions, so the function signature is its name and the parameter types. That's the function signature. So we can have two functions with the same name but different signatures. So here I've got a function called do something because I was lacking inspiration. I couldn't make it about dogs. A function called do something that takes an int. And I've got another function called do something that takes a double. Now these are different functions, right? It's not an error to have both of these functions. It's a perfectly valid thing to do.
Because they are different.
Because they're different functions, because they've got different parameter types. One takes an int, one takes a double. It just so happens that in this example I've given them both the same return type, but that's not necessary.
It's in fact irrelevant. You can't overload on the return type.
You can give them different return types if you like. What you can't do is give them the same parameter, have the same parameter list and different return types. That doesn't work, right? It's only the name and the parameter list that forms the signature of the function, right? So here we've got two functions, both called do something. They take different parameters. Do something is what we call an overloaded function. which is called function overloading. So when we've got overloaded functions and we try to call a function, when we call a function we supply the arguments, right? Call a function in the brackets, we write the arguments, the data we're giving to that function. The compiler tries very hard to work out which function, which of the overloaded functions best matches the arguments we've supplied. It's a process called overload resolution, and it is enormously complicated, right? I reckon it's one of those things where it's like general relativity. Like there are 3 people on Earth who really understand it, right? It's very complicated, the way it actually works, like deep, deep down. But in simple cases, it's pretty easy to understand. So let's have a look at it now. We've got a function. This is not a member function, by the way. We've stepped back just for a few moments from member functions. We're just talking about ordinary functions here, ordinary non-member free functions. Print a function called print, takes an int, doesn't actually do anything with it, it just prints 1. And I've got another overload of prints. This one takes a double. Everyone with me so far? Nothing up my sleeves. An int. I call print and pass it an int. What's going to happen when I do this? This is not a trick question. It's going to print 1, absolutely. It's going to say, okay, I'm going to look for a function called print that takes an int. You've passed me an int. And it's going to look at this and say, can I convert an int to a double? And actually, yes, you can. Right? So it could, if this didn't exist, it would call this function. But it's also going to look at this one and go, well, I don't have to convert an int. In order to call this function, I don't need any conversions, right? I can just plug the int straight away. So this one's actually a better match than this function. So both of these are valid, but this one is a better match, right? You're beginning to see why this process is complicated. This is the simplest case I could think of. But yes, as you would hope, as everybody has guessed, this prints what? It selects the first function.
So is the match instructions, number of instructions?
Technically, it forms something called a conversion sequence, and the one with the shorter conversion sequence is a better match. So in this case, there is no conversion sequence required for the first one. The second one requires a conversion, so it has a lower rank. It's getting a bit trickier now. Got a float. I want to print my float. It's a sneaky one, this. What do you think is going to happen here?
2. Yeah, I think.
Sorry?
I think 2.
2? Yeah, you're all right. Yeah, well done. So, what's going to happen is say, got print, pass me a float. It's going to look at these signatures, go, okay, well, actually neither of them takes a float. So to call either of these functions, it's going to have to do some sort of conversion, right? It's either going to have to convert f to an int, or it's going to have to convert it to a float in order to call this function.
What if I want to force, I got preference which one should choose?
Then you could use static cast to change that into an int or a float. Right?
Static or dynamic?
Static. Yeah. You have, yeah. Definitely not dynamic. I don't know where you've got the idea of dynamic.
Dynamic is during the run, yes?
Yeah, but you want to select the overload, right? So that's Definitely a compile time thing.
Okay.
Yeah. Anyway. No. Right. So here we've got a float. We want to print it. Either way, a conversion is required. So it says, can I convert a float to an int? Well, actually, yes, you can. Can I convert a float to a double? Yes, you can. But, and again, we're getting into, we're just getting a little glimpse of why this process is pretty complicated. Converting to a double is a better conversion because we don't lose any information. Right? If we convert a float to an int, remember we throw away the fractional part. So this is a worse conversion. They both need a conversion, but the conversion to an int is a worse conversion. This is a better conversion. So it picks this function. It calls print, the double version of print, as you would expect. Yeah?
So what happens if you send it a string?
If you send it a string, it will say, all right, can I convert a string to an int? No, I can't. Can I convert a string to a double? No, I can't. And I'm out of options. So it'll give you an error. It'll say no matching function for print string.
If it was a jar, would it go to ASCII?
A car,
Car, so jar, car.
a car, like a raw car.
Just
Yeah, that. So if you were trying to, if you had like car C equals single quotes A, and then print that, it would select that because car to int is a better conversion than car to double.
But you could have another one, void print and then string, I think, yes? Am I right?
Yeah. Did you have a question?
Maybe you skipped it in the intro slides for the function overloading. What's the point or the value of having function overloading? Apart from that, you can do it, it's nice and fun.
You can do it, it's nice and fun, but it allows us to do what's called static polymorphism, right, which is a fancy way of saying do the same thing for different types. Right, so later on in the course we'll talk about templates. And templates are another way of doing this static polymorphism thing. So the idea is you have, like, let's say toString. So in the standard library there's a function called toString that takes, well in fact it has many, many different overloads. There's an overload for every kind of ints, for floats, for doubles, for bools, right? And so this toString then is a kind of generic function. So whatever kind of argument you give it, you just call toString, and out you get is a string that contains whatever. Right? So the idea is you have one interface, that is the function name, that can operate on many different types.
Sure. Okay, so depending on what you pass it, it will choose.
It will choose the appropriate function. Yes, absolutely.
And you call it static polymorphism because you need to know the set.
Yeah, exactly. It chooses which version of print at the time you compile the function, or you compile the file. Yes. Yeah.
Is C out an example of that?
Sorry, see out.
An example of that?
Yes, actually, yeah. Well, okay, see out, strictly speaking, is not. That's an object. But this, we're going to talk about operator overloading in a few minutes, and this is actually an example of an overloaded operator. So yeah, that's very well picked up. Yeah. Okay. That was a very brief intro to function overloading. Let's have a little more fun, right? That was too easy. This time.
Sorry, can I say one thing?
Yeah.
Because I was thinking maybe if you could open up that, if you look at the way you add fractions and you add whole numbers as well.
Yeah.
Because you could have a function called add number.
Yeah.
The way you add fractions and the way you add integers are very different.
The brilliant example of why you would have the same function name but with different kinds of arguments. Absolutely, yeah. Very good. Good example, yeah. Yeah, so this time we've got a function called print. Takes a const reference to an int. And now I've got sneaky. I've got a function called print that takes a non-const reference to an int. Right? Now this is completely valid to do. You can have an overload that takes a const reference and an overload that takes a non-const reference. That's perfectly fine. Now I've got int I. I call print. Now we start thinking, which one's it going to prefer?
It prefers
Well, we just say we're not gonna
Two. All right, people are yelling 1 and 2 at me. There was a
the reason I thought it wouldn't go for 1, because in one I'll be saying we're not going to make any modifications to whatever we pass in.
Yeah.
So it would not be 2 then.
You've got the reason absolutely spot on. This int is not const, right? This is a mutable read-write value. We can change this. So it's going to look, and it's going to say, okay, I've got 2 choices. Either I've got the one that promises not to modify anything, or the one that might modify it. Well, you've given me something that's modifiable, so I'm going to choose this one. Right? This is a better match than this one, in this case. So this prints 2. What about here?
There's only one.
Yeah. Okay. This time it says, okay, I've got a constant. I can pass a constant into this function, that's fine. What if this function didn't exist and I just tried to call print? If the top one didn't exist, if I hadn't written that, if I just had this function, what would happen? Would it?
It might not compile.
Absolutely, it wouldn't compile. Because this is saying, I have a read-only variable called ci, and this is a function that's saying, I might change the argument you give me. Right? So the compiler is going to say, I'm not going to let you call that. That would be a compiler. Right? So it's going to look at the potential overloads of print, and it's going to say, well, hang on, this one's out of the equation. I can't possibly call that. So it's going to prefer that one. There's only one candidate. This candidate disappears. So this idea of overloading is quite important in C++. It pops up an awful lot. So this prints one. This idea of overloading pops up an awful lot. It's kind of quite important for various things. And as you can see, it actually can sometimes be a bit tricky to work out. Because if you think about it, I've only shown you examples where there's one parameter. Now you can have 3 or 4. And it's got to look at the potential conversions for each and every parameter and order them and work out which. It's really complicated. But it generally, most of the time, does the right thing, does what you expect it to. A lot of very smart people spend a very long time writing the rules so that most of the time it does what you think it's going to.
So you get an overload that takes an int and one that takes a concept.
Yeah.
You use null from C.
Yeah, there are awkward cases, but so everything I've just said refers to non-member functions, free functions, ordinary functions, the functions we're used to. But it also applies equally well to member functions. We can have a struct that has 2 member functions with the same name, but different parameter types. So here I've got a struct example. which has two member functions, both called do something, one of which takes an int and returns an int, one of which takes a float and returns a float. So this is the exact same case that we had when we were looking at the non-member functions, except this time they're members of struct example. So create an instance of an example. We call e.doSomething with an int. Well, as you would hope, as you would expect, it's going to call this one. But if we pass it a float, it's going to call that. So this is not surprising. It's the exact same rules that we had for free functions. But the point is, you can have overloaded member functions. And if you look at standard string, for example, I don't know if anybody's looked that up on like CPP reference or something. It's got over 100 member functions, some of which have like 10 different overloads. It's crazy, crazy. So yes, we can overload ordinary functions. We can overload member functions. Now, here's the bit where it gets really funky. You remember how we put the const at the end to say this function, I promise it won't change. This member function will not change any of my data members. For member functions, we can have two different overloads, one of which is const and one of which is not. So our familiar struct points. Now, point has got two member functions. They're both called equal to. They both take the same parameters, but one is const and one is not. And this is perfectly valid. This is allowed, right? We're overloading on what's called the const qualifier. That's this const at the end.
Would you mind just remind the constant here what exactly will do? How is it different from the previous one, the one above?
Okay, so you always call a member function on an object, on an instance, right? So this first version says, no, sorry, the second version says, I promise that I cannot modify the instance in any way. The first one says, I might change the instance. Okay. So when we have a const qualified member function, const member function, you cannot change any of your member variables inside this. All your member variables become read-only inside this. Here, your member variables are writable. You can write them.
So we're not talking about the parameter,
No, we're talking about these member variables here.
Okay.
So within the body of this second function, we cannot change x or y. Within the body of this function, we potentially can change x or y if we want to.
And what would happen if we would have const int x, const int y?
Const there and there.
Yeah.
Then you wouldn't be able to change them in either member function.
So it would be pretty much obsolete whether we have the const at the end of the.
Correct. Yeah.
Okay.
Okay. So now I've created this point P, 3, 4. Now I'm saying is P equal to another point, 3, 4. So it's just a temporary I've just created for this. Now P is not const. So just like we had that second example, where we were calling print on a const or a non-const, here P is not a const object. So it's going to look at both of these and go, okay, they're both valid, but since I'm a non-const object, I prefer the first one. So it's going to call the non-const equal to. It's going to call the first one here.
Why is it?
Sorry?
Is it purely because the point P and the
That's precisely why it is, yeah.
If I was to put that in English, first one basically says, I'm not going to alter the arguments we sent to you. Yeah?
Not the argument, the object
The variable.
that I'm being called on.
So basically, I'm not going to. Yeah. So this thing I'm working on. So what's the second one saying?
So this second one with the const says I'm not going to change it. I cannot change it.
What was the first one?
The first one says I might change it. I am allowed to change it.
As I'm saying it, you say it, because look, we're saying, okay, let me try and do this.
Okay.
So I thought the English was, when you put the const, when you put the const in the argument that you're sending, you're
Yeah.
saying, okay, I promise you I won't trouble the argument you're sending.
Yeah.
But when you put the const at the end of the function, you're saying, this thing, I won't change any of the behavior or any of the armed statement, the thing I'm actually working on. That's what it is.
That's correct, yes. Yes. Yeah. This const at the end says I cannot change the state of the object that I'm being called on.
You could have one more version, bool equal to point reference order close bracket const. So basically, the const from the bracket could be gone as well. Right?
Could I have another overload that got rid of that const?
Yeah.
Yes, I could.
Yeah, you could. That wouldn't make any point in this particular case, but yes, you could. The way to perhaps look at it is that it says it won't modify itself. So equal to says I am const, I will not modify myself, and you are allowed to use me when you have a const instance of my type, i.e. point. The one that does not declare const says you can use me when you have a non-const instance of me. When you have a const instance, you can't.
So this time, so in this case, P was non-const, so it calls the non-const equal to. It's probably not so surprising. This time we have CP, which is a const point. So CP is const. When we call equal to, well, we cannot possibly call this member function because we're promising CP says I cannot be changed. This function says my state can't be changed. This function says I might change the state. So we can't possibly call the first one. So it calls the second one. So it calls the const qualified version of equal to. So this idea of overloading on const qualifiers is kind of weird. And as far as I know, there aren't actually any other programming languages that do this, right? C++ is really keen on this what's called const correctness. And it's a little bit strange to kind of get your head around. But it does have some valid usages, and that's why I'm sort of introducing it now. Particularly when we get to talk about operator overloading, which sadly, I think with 8 minutes to go, is probably not worth me starting to talk to you about now. Let me just see. How far can I go?
I mean, this isn't code note, we're not getting kicked out, but we'd have to end exactly at 9.
Well, no, people have got places to go, haven't they?
No, I wasn't suggesting you go on for another half hour or something.
All right. I'll tell you what I'll do. I'll give you like an 8-minute, very high-level thing of operator overloading, and then we'll talk about it properly next week. Right. So first of all, what's an operator? An operator is a bit of punctuation. You've already used a lot of operators, right? So when you did x equals other.x, that equal was an operator, right? When you do assignment, when you say x equals y, that's an assignment operator, right? When you say is x less than y, that's the less than operator. So the built-in types, ints, floats, what have you, they have all these operators are built in, right? So you can just say, is my int x less than my int y? And that's a built-in operation. built-in operator. C++ allows us to implement operators for our custom types. Almost all the operators in C++, you can define what they mean for your custom types. So for example, this point that we've been reusing all night, we can define what equals equals means when we're comparing 2 points. So we wrote a function called is p equal to q, right? But that's not how you would write it for an int. For an int, you'd say p equals q. And C++ gives us the facilities to define what the equals equals operator and lots of others, define what that means for our point type. And it's a process called operator overloading. So we've just heard about function overloading. By overloading we mean having the same name but taking different types. In this case, the operator has the same name, but we are being able to use it with different types. So we're overloading the meaning of that operator. Okay, so the way we overload operators is we do so by writing a function with a special name. So we write it as operator, and then whatever the punctuation symbol is we want to implement. So in this case, we want to define the equality operator for our points. So really inconsistently, sometimes spelled with a capital and sometimes not. Sorry, I'll correct that when I go through the slides again. So here we're saying, I want to define a function, I want to overload operator equals when I'm comparing 2 points. Think about it, equals must take 2 arguments. You have to have a thing on the left and a thing on the right.
Perhaps to make it a bit less confusing, you can literally write operator equals and pass it 2 arguments too, and get the result.
And obviously we want to return a bool, because either they are equal or they're not equal, true or false. And once we've written a function like this, then we can just use the natural syntax, the natural equals syntax for our types, just for our points, just like we can with ints. And here we go again with the capital P's. I've really got to change this, sorry. So, assuming we've written this function, now, if we create 2 points, we can assert p equals q. So, the goal of almost everything, well, I say almost everything, the goal of many things in C++ is to make user-defined types behave just like the built-in types do, right? References are part of that, and operator overloading is a major part of that. So pretty much anything you can do with an int, you can write your own struct class type that does the same thing. So here we've got equals, but there are a whole raft of operators that you can overload. There's plus, minus, times, divide, modulus, caret, address of, logical or, logical not, no, not bitwise not, sorry, logical not, comma operator, which is, yes, don't even ask. The assignment operator, all of these. Like,
What about the dot?
what about the dot? So when it says almost all, the dot is one of just 3 exceptions. And there are good reasons for that, but believe it or not, they are Straustrup himself has proposed changing that to allow you to overload the operator dot. There are good reasons not to do it, there are good reasons why you want to do it, but at the moment you can't and you won't be able to in C++ 20 either.
What does it mean when you have a question mark and then a variable?
A what?
A question mark,
Sorry,
exclamation mark.
exclamation mark.
This means, so if you say exclamation mark and then a bool, it's the opposite. So not true is false, and not false is true. So it does the logical opposite.
It's a not.
Yeah, not. So to leave you tantalizingly on this, we can overload almost all our operators in C++. The vast majority of them it doesn't make sense to. However, we can overload quite a few of them where it does make sense. So here I will leave you with a question. Given our points, now I've gone back to a small p, given our point class, which operators does it make sense to overload? Because we can, pretty much anything you can do with an int, we can define what that means. Somehow, right? Which operators, that big list I just put on the screen, which ones would it make sense? I've already said equality probably makes sense, right? It makes sense to say, are these 2 points the same?
Adding 2 points together.
Adding 2 points?
Yeah.
I was gonna leave you with this to think about, but you know. Sorry? Greater than, less than. Less than. The bit shift.
Shift operator.
Well, cout's an interesting one, and we will talk about that next week because it's 9 p.m. Time to let you all go. Thank you for coming, and I hope to see you next week. Please do, those of you who can make it on Thursday. I'll put up some homework. People had a really good go at it last week. That was great. So, yeah, if you can make it on Thursdays, please do come along. Is it a code mode this week?
Yes. So can you please RSVP on Skills Matter website? Everybody knows the website? Skillsmatters.com, CPP Londonini, and RSVP for our class. The sooner you do, a bigger chance we have the big room, not the small cubicle.
All right. Thanks very much, everybody.